The Ice Cream Palace serves 5 different flavors, including mint and strawberry. There are 2 toppings, gummies and sprinkles. For an additional charge, they can serve your ice cream in a waffle cone. How many different 1-scoop, 1-topping ice creams can you order? So let's start by listing these all. This might actually work. So you can say mint, gummies, and waffle cone. And you can say strawberry, gummies, and then waffle cone. Oh yeah, and then there's also mint sprinkles in it. Oh, this is definitely not gonna work. Since I can't stay organized, like how do I know if I count just 1,100,000,000 times? Or like, if I miscounted some, like, I don't know how to stay organized. How do I, like, make sure that it's my true answer? Let's do it this way. So, to order my ice cream, I'm gonna first have to make way for the flavors. First I have to decide my flavors. I'm gonna write down flavors here on the side. Phew. And then I know there's a whole bunch of flavors, 5 different, but I don't think we need to write them down. We'll just use A, B, C, and D to represent all the flavors, not writing them all down. So we'll just write A, and then B, C, D, and then finally E. So now, what is our next choice? Well, it says here that there are 2 toppings, gummies and sprinkles. So we have to now choose our toppings. Right, topping down here. And then we'll write, should I add an S? Okay, so now I'll write 2 little lines coming out of this little A. And these are branches. Since this is what we're doing here, what this is gonna lead to eventually, it's a complete tree diagram. And what do trees have? Branches, right? And what do branches do? They connect the tree to the leaves. This is exactly what it's doing here. The branch is gonna connect one option to another option. For example, we're gonna use gummies to stand G for gummies and S for sprinkles. So if we're here at this S, we have flavor A, whatever that is, and then sprinkles here. Same thing here. We'll have 2 branches coming out of G and S for gummies and sprinkles. We can keep doing this until we end up at the E. This is a little word, so. Okay, so now we have, these are all our options we will have if there is no cone, which is a little weird. So we've now got to order our cones, since how do we eat ice creams without cones? So instead of writing cone, it could be like a traffic cone, we'll write waffle cone. Yeah, we'll write waffle cone. Waffle cone. Let's use this little space down here. Waffle cone, but then we'll add a question mark, because if we don't, it'll look like we have to it'll look like we have to order the waffle cone. So I want you kids to think that we have to order a waffle cone, since if we do have to, we won't have to draw anything, since then we'll just have one option which is sticking out. It will just be the same as all these. But here it didn't say you have with a waffle cone. It just said you can order your ice cream with a waffle cone. So each of these, we're gonna say N or Y for yes waffle cone, or no waffle cone. I'm gonna write N and Y, another 2 branches sticking out from each of these new different possibilities. So I'll write an N and Y for each of my possibilities for my branches. And again, what this means is if I'm here at this Y, I have yes waffle cone, I serve my ice cream in waffle cone, and I have gummies as my topping, and I have flavored B, whatever that is. So it's the same, and to count exactly how many possibilities there are, all we need to do is count all these endpoints. But if there aren't any of these, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different possibilities already. So we'll keep going until Again, we get this aspect down here. Just again, and then eventually we'll get there right now. So now we've got all our endpoints. So this is actually how many different combinations of one scoop, one topping ice creams you can order at the Ice Cream Palace. Let's count all these up. There isn't really a good way. So 2, 4, 6, 8, 10, 12, 16, 10, 12, 14, 16, 18, finally with 20 options total. So we've just figured out how we got 20 in our tree diagram. So this 20 is correct, but we don't actually need this big blob right here. We could have just used possibilities and multiplication to solve this. Think of it this way. We've got 5 different toppings. We got 5 different flavors down here, correct? Yeah. So we got 5 down here. And for each of these 5 possibilities, there's 2 more toppings coming off of these branches. 2, right? So what this equals, without these all and then y's here, we would just have 2 times 5 different possibilities without the cone. So we got 2 times 5 possibilities. And then here, for each one of these, we have another 2 sticking out up here. So again, we have a regular old. This is much easier, right? Than just writing this big mess here. So this is actually the exact how much this is here. So way faster to count, right? So let's compute this. That's all we have. 2 times 5, 10, 10 times 2. It's just 20. So this is much quicker, right? This video is much quicker. So you can compute anything, like if there are 6 toppings, 9, if there are 6 flavors, 9 toppings, and 2 different 4 cones, it will still be the same, just use multiplication. And still 20. Didn't change anything.